Alright, so today we're going to start some new material. You can read the title here. It's Angles in Standard Position. Okay, so we're still talking about angles. We'll still be dealing with trig, but we're going to be doing something different. And the one thing I always say about this lesson is that it is riddled with terminology. So once you get the terminology in your head, things are going to be good. So you do have to practice and you do have to read through this, okay? Make sure you read it after you've listened to it, okay, to make sure that you're actually understanding what's happening, okay? Alright, so the primary trig ratios were defined in a right angle triangle, okay? So the triangles were acute, less than 90 degrees. So some sine law and cosine line questions involved obtuse angles between 90 and 180 degrees. A new system defined on the xy plane is needed to consider larger angles, so angles larger than 180 degrees and actually larger than 360 degrees, which is one full rotation of a circle. Alright, so an angle is formed when a ray is rotated about a fixed point called the vertex. Now I'm just going to do this, I'm going to draw over top of the writing here, but I'm going to do it with highlighter. So the first ray that is formed here, let me just do that better, is called the initial arm. Okay, so that's the initial arm, and the initial arm always sits on the x-axis. Okay, if you're looking at the plane of x and y axes, so it's always here, and the vertex, because it did talk about vertex, is right here. Okay, so it's where the ray starts. All right. Now, there's also a terminal arm at the end of the angle. So when we're measuring an angle, like say if I asked you to draw a 60-degree angle, you would draw that line and then you would measure out your 60 degrees, right? And it would be this portion in here, which would be the 60 degrees. All right, so what I'm looking at here is that this is your terminal arm. Okay, the yellow one is the initial arm. Okay, so you need to know the difference between the two, and you need to know what angle we're looking at. All right, so an angle is in standard position if the vertex of the angle is at the origin, which is the point 0, 0, and the initial arm lies along the positive axis. So that's what I was talking about here. If that's always going to be on the positive x-axis, then it will always be in standard position, which is the regular way that we're going to draw it regardless. Okay, so it says note that an angle can either rotate clockwise or counterclockwise. And I want you to look at this for a minute, the one that I drew up here. When we drew this, or when I just sketched it, it was this angle that I was looking for, right? So what direction does that black arrow go in? Is it clockwise or counterclockwise? Well, it's counterclockwise. Clockwise goes this way, right? Like the hands of a clock. And I know you don't always look at clocks that have numbers like 1 through 12 because you're always looking at your watches and digital clocks, but you need to look at the older type of clocks, the analog clocks, and that's clockwise. This is counterclockwise. So that's why we look at these angles in standard position that rotate clockwise, so this way, they're going to be negative angles. Okay, and that's going to be new to you guys because normally you don't see negative angles. So angles in standard position that rotate counterclockwise are considered positive. So this is a 60-degree angle, and this angle would be a negative angle. Okay, now that's going to become very clear when we get into some other drawings here. And I made sure that I had all of this preset because it would take a long time to draw it all in. Okay, so highlighting is going to be the way to go here for this particular exercise. All right, so it says draw each angle in standard position. All right, so this is your initial arm. Sorry, I want it to be a little thinner than that. So this is your initial arm. And notice it's going to be the initial arm every single time. Okay? Because it's the first one you're going to draw. Then you've got to look at 240 degrees and ask yourself, what quadrant is that going to end up in? So 0 to 90 is in the first quadrant, 90 to 180 is in the second quadrant, 180 to 270 is in the third quadrant, and then 270 to 360 is over here. So this one falls in the third quadrant. So you're going to draw your line down here. I by no means do not want you to grab a protractor and measure it all out. Okay, you're just eyeballing it. If you get it in the right quadrant, I'm not going to say, oh no, it should be a little smaller than that or a little larger than that. Just get it in the right quadrant, okay? So if we're measuring, then this is the measurement that we're looking at, right? The angle is going counterclockwise, therefore positive, okay? And that's it. There's your angle of 240 degrees. Now if I want an angle of 315 degrees, again, I'm going, it's a negative angle, so I'm going clockwise. So I have to go 315 degrees from my initial arm. So I'm going 90, 180, 270. So it's got to end up in the first quadrant. So there you've got your line here. And again, it's being measured this way. Now, your quadrants are marked down here. And I know I keep saying first quadrant, third quadrant, or whatever. But you should know this by now. Okay? First, second, third, fourth quadrant. I'm expecting you to know where those are. Okay? Alright, so 640 degrees. Again, there's my initial arm. It's a positive angle, so you are going here. You notice, I hope, that this is greater than 360 degrees. So that means I've got to go one complete rotation. Now, the interesting thing about this is that from my initial arm, this is one rotation. Right? That's 360 degrees, but I need to go a little more. So you actually have to know how much more. So you're going to take 640 and you're going to subtract 360 because you know that's one rotation. And you're going to find out, I guess I should do it, that it's 280. So you have to go 280 more degrees after that one rotation to get to where we need. So from here, I'm still going to do this in a different color. You've got your 90 degrees, you've got 180, and then you've got 270, and then it takes you into that third quadrant, or fourth quadrant, sorry, because you've passed 90, 90, and 90, so there's 270. It's 10 degrees into that fourth quadrant here. So that, let me just get out my thing here. This is going to be your terminal arm. Sorry, I wanted that to be thin, but this is going to be your terminal arm here. Okay? You have to have this little spiral indicated so that I know it's going one full rotation and then going on from there. So don't just go from here to there, because that'll tell me that that's just 280 degrees as opposed to 640. Okay, it's really important. And you can have positive and negative angles that go and use the spiral. Okay. All right. So far so good, I hope. When you draw an angle in standard position, the related acute angle is the angle between the terminal arm and the x-axis. Alright, so x-axis, terminal arm. X-axis, terminal arm. I'm trying to get this as nice as possible. X-axis, terminal arm. Okay? So, the related acute angle. I'm going to draw it in here. Okay, so it says draw each angle in standard position and label the related acute angle. Okay, so If it's 300 degrees, then you know that's going to end up, excuse me, in the fourth quadrant. So you're going all the way from here to here. That's your 300-degree angle. Okay. Now, the related acute angle is the angle between the terminal arm and the initial arm. So it's this angle in here, and I'm going to make it red. Okay, that's how much the related acute angle is. But now you actually have to figure out what that distance or what that degree measure is. So if you're going 300 degrees here, how much more do you have to do one complete rotation? Well, it's got to be 60 degrees. So in this case, the related acute angle is 60 degrees. In this one, we are looking at, oops, I did that wrong. We are looking at your initial arm being here, sorry, and the terminal arm being here. Now, it's a negative 135 degrees. So, negative 135, it's going to go clockwise. Okay, so it's this angle that we're looking at. That's negative 135. So it stops in the third quadrant. Now, the thing here is, you are looking for the related acute angle. Now, the related acute angle is the angle between the terminal arm and the x-axis. Well, this is still your x-axis, and this is going to be where your related acute angle is. Now, again, you've got to figure out what that degree measure is. You should know that the x-axis marks the 180 degree mark, right? Whether you're going negative or whether you're going positive. So going here, you need to know how much more would I have to move to get to my 180 degrees. Well, you're going 45 degrees. Now, the related acute angle is always, always, always going to be positive. Please remember that. So anytime you are asked to give me the related acute angle, make sure it's a positive angle. Okay. All right. So this one here, negative 750 degrees. All right. So obviously more than one rotation. Is it more than two? Well, what's 360 times 2? It's 720. So yeah, it is going to go over 2 rotations. So you need to look at that and make sure that your spiral indicates that. Now again, it's negative, so it's got to go clockwise. So you're going 1. I'm just going to do this in different colors. And then you're going to go another rotation. And then there's going to be a little more, right? Because that's only 720. So that's the extra 30 degrees, which is here, for your related acute angle. Because again, here it's going to be harder to see here. But this, because of all the spirals, I don't want to get too close in here. This is going to be the measurement of your related acute angle. And again, even though I know we're going in a negative direction, you want to keep it a positive angle.